Previously in this learning path, we have touched upon the topic of closures. We covered what they represent from a theoretical standpoint, and even during the labs, we have in fact implemented a few examples of closures. In this demo though, we will see exactly what they represent. So once again, we have an HTML which goes with a JavaScript which it points to. And let us head over to the JavaScript source file. The first thing we do here is to enable strict mode. And then following that, we define a function. This function called patient is in fact an object constructor, and you can consider that it represents the patient at a hospital. Any instance of patient which is created will need to supply an ID, a name, an address, and a blood group for the patient. Both the ID and the name will be attached to the patient instance, and we can make them publicly accessible by setting these values to this.id and this.name. We will see exactly what that means just a little later. This is in contrast with the address and the blood group. So we define two variables using the var keyword, and these variable names begin with an underscore. The address and blood group values which are supplied will be assigned to these variables. These are in fact private variables when creating objects in JavaScript. And we will contrast this with the ID and name variables just a little later. So we now have an object constructor which accepts 4 different values. And to go beyond that, we also include a print details function which prints out all of the details for a patient. Note here that we access the ID and name fields using the this keyword, but the address and blood group variables are accessed as is. You will recall that the definition of a closure is a function which is bound together with all of the variables in its surrounding scope. In our example, the combination of the print details function along with the address and blood group variables defined just outside of it will form part of the closure. This concludes the definition of our patient object constructor. So let us go ahead and initialize an object. So this one is called first patient, and it represents someone called Tanya Wells who lives in Asheville, has a blood group of B positive, and her patient ID is 12. With that, we can go ahead and print out the first patient object to the console. When we do that, we will see exactly what this object looks like, including what makes up the closure involving the print details function. To check that out, we can save down the source, bring up the HTML in a browser, and once it loads, let us pop up the console. So we can see that the patient object has been printed out here, and upon expanding it, we see that it includes the ID and the name fields, and also the print details function, but the address and the blood group fields are not visible here. So how exactly can we access them? Well, for that, let us expand the print details function, and within that we can see that there is a function location which points to the definition of the function within a closure intro.js file. But right below that, we also have a scopes array containing 2 different scopes. And upon opening it up, we observe that the first of these scopes is a closure. I'll just go ahead and expand that, where we can see that this closure includes the address and the blood group fields from the enclosing patient function. So this is precisely what a closure is, where it is the print details function bundled together with the variables defined in its surrounding scope, which in this case are address and blood group. You'll observe that the global window object is also part of the scope for the print details function. So a question at this point is, how exactly are these 2 variables, address and blood group, different from the other 2 variables within the patient function constructor? Well, to illustrate that, we can head back to the code, and then from here, let us print out the ID and the name, and we do that by invoking the dot operator for the first patient object. So, will we be able to access the ID and the name using firstpatient.id and firstpatient.name? Well, we head over to the console to test it out. And the answer is yes. So the values of 12 and Tanya Wells are accessed as expected. However, what about the other two fields which were defined using the var keyword? So I'll just pop in the function definition here, where we have the ID and the name, which were initialized using this, but address and blood group were declared using var. Can we access both the address and the blood group using the dot operator? Well, when we head over to the console to test it out, the answer is no. Both the address and the blood group are undefined. This is because when a variable is declared inside a function constructor using the var keyword, it is not bound to the object which is created from that function constructor, but instead it becomes part of the closure of any nested function. So in our case, the print details function should be able to access these variables. Bringing up the function definition, you can see that the address and blood group variables are not accessed using the this keyword since they are not part of the object, but in fact referenced directly, since they are part of the closure which includes the print details function. So, heading over to the console, let us check out whether the print details function is able to print out all four of the fields which it is trying to reference. And the answer is yes. So the ID, the name, as well as the address and the blood group are accessible. The first two of these are part of the object, which is why they are referenced using the this keyword, while the address and the blood group are part of the print details closure. Heading back now to our source code, let us leave the initialization of the first patient object as is, but then comment out all of the console.log messages. We then go on to defining a new second patient object. This represents a patient called Dean Taylor, who is from Madison, and his blood group is A negative. We start out though by printing out the entire second patient object to the console. So, heading over to the browser, we head over to the console and expand this second patient object. The ID and the name are accessible at the object level. And when we expand print details, I'm first going to expand this proto field here. And you can see that the scopes are accessible from here as well. And within that, we have a closure containing the address and the blood group fields from within the patient object. And even when we expand the scopes from within print details itself, we can see the same closure. So when variables are declared using the var keyword inside a function constructor, they effectively become private variables which can only be accessed by the object's functions. So while the address and blood group here can be considered sensitive information, in order to prevent unauthorized access, they can be declared using the var keyword as we have done in this example. Heading back to the source though, let us see what happens when we invoke the print details function for the second patient. And from the browser, we see that all of the details for Dean Taylor are printed out as expected. Now it is important for us to confirm that both the first patient and second patient objects have different values for each of the fields and that their closures are in fact pointing to different variables. To confirm that, let us first go ahead and make a change to the first patient name. So we set this to a value of Dean Thomas. And then we follow this up by invoking the print details method for the first patient. And when we head over to the console, we see that the details for the first as well as the second patients are different. We had deliberately assigned them the same patient IDs, but the names, the address, as well as the blood groups are bound to separate objects and closures. Now that you have some familiarity with the concept of closures in JavaScript, a few questions need to be asked with regards to the scope of variables. So we can have variables declared in the global scope, which could be accessed by nested functions. These nested functions can also access variables declared within the closure scope and also those inside the functions themselves. This demo focuses on how having variables of the same name declared within these different scopes could affect the value of the variable accessed by a nested function. So we once again have an HTML and JavaScript file, and I'll just head over to the JavaScript which is being pointed to. We start off by defining a variable as well as a function in the global scope. So here we declare a constant value called pi, and we set this to a value of 3. The function in this case is an object constructor representing a circle. The constructor accepts one argument, which is the radius of the circle, and then assigns this as one of the object's properties. Beyond this, we will now define one more function within the global scope. So this is called getAreaFirst, and this is one which calculates the area of a given circle, and it is that circle which is passed to it as an argument. So you see here that it calculates the circle's area as pi times the square of the circle's radius. Question to ask in this case is, what exactly is the value of pi which is being accessed by getAreaFirst? We can presume that it is the pi which is declared in the global scope, and this is something we will confirm just a little later when we invoke this function. Before we get to that, however, we can declare an object of type circle. So this is called first circle, and its radius is set to 10. Beyond this now, let us declare a function inside the global scope again, and this is called inner function, and our aim is to define a few nested functions within inner function. Before we get to that though, we will define a value of pi within the scope of inner function. So this is set to 3.1. You will recall that the variable pi in the scope just outside of this has been set to a value of 3. Now, we declare a second function to calculate a circle's area. This is called getAreaSecond, and you'll observe that the signature as well as the body of the function is identical to getAreaFirst. What we need to resolve with this function is what exactly is the value of pi which it accesses. Given that this is a nested function, there are two possibilities. It could access the value of pi within its closure, which is 3.1, or it could access the global value of pi, which is 3. We could check whether the closure variable in this case is ignored or whether it overrides the global variable. Moving along, we declare one more function, which is a nested function. This is called getAreaThird, and this one has a value of pi defined inside its own scope. So this is set to 3.14. This function also calculates the area of the circle as pi times the radius square, and we need to see whether it is the local value of pi which is being used, which has declared pi up to 2 decimal places, whether it is the closure variable of pi, which is 3.1, or whether it is the global value of pi, which is 3. And just to make things a little more interesting, we now declare a third nested function within inner function. This is called getCircumference. This does not have a local value of pi, but it does reference pi in order to calculate the circumference of a circle. So given that we have 3 different nested functions within inner function, in addition to the globally declared getAreaFirst, the question is what value of pi each of them references. To test all of this out, we will now declare a second circle variable. So this is a circle with a radius of 20. And then following that, we invoke getAreaFirst from inside inner function, and the argument which we pass to it is first circle. So note here that getAreaFirst as well as first circle are declared just outside inner function. So in order to carry out our experiment, we will now invoke inner function from the outer scope. And the question for us to answer in this case is, given that getAreaFirst is being invoked from inside inner function, what is the value of pi which it accesses? Is it the one in the global scope, which is 3? Is it the one declared within inner function, which is 3.1? Or is it accessing the value of pi declared within getAreaThird, which is even more precise at 3.14? So we head over to the browser to carry out our test, where we pull up the HTML. And once it loads, let us head over to the console. And what we observe is that the area of the circle is being calculated as 300. Given that the area of first circle is 10, it means that the value of pi which has been taken into account is 3, and this is the one which was declared in the global scope. So even though getAreaFirst was invoked from inside inner function, the value of pi which getAreaFirst has referenced is the one which was declared within its immediate environment. That is, it was part of the closure of getAreaFirst. In the next video, we will invoke the remaining functions which we have declared and see what values of pi each of them reference. In the previous video, we invoked getAreaFirst from inside inner function and saw that the value of pi which is referenced was the one declared in its surrounding environment in terms of where it was declared, rather than where that function was called from. Moving along, let us now invoke getAreaSecond, and we once again supply the first circle with a radius of 10 as an argument. Now, given that getAreaSecond is declared within inner function, we need to see what value of pi it references. So, heading over to the browser and refreshing the page, this time we get a calculated area of 310. So the value of pi which was referenced was 3.1, and this was the one declared within inner function. That is, it was within the closure of getAreaSecond. One conclusion we can draw from this is that the variable pi declared inside getAreaSecond has overridden the one declared outside of its scope. And also, given that both getAreaFirst and getAreaSecond have been invoked from inside inner function, the fact that they have referenced different values of pi means that the variables being accessed depends on where the function is declared rather than where they are called from. Alright, we can now continue with our experiments, and this time we will invoke the getCircumference function, once again passing along first circle as an argument. Now this is one declared within the scope of inner function, and you may expect that this will access the value of pi, which is 3.1. The goal of this experiment is to make sure that both getAreaSecond and getCircumference are able to access that same variable pi, and that closures in JavaScript don't restrict how many nested functions a closure variable can be part of. So heading over to the browser, we can see that both getAreaSecond and getCircumference reference the same value of pi, which is 3.1, which is why the circumference is calculated as 62. So the variable pi, which we set to 3.1, is part of the closures for both getAreaSecond and getCircumference. So heading back to the source, we will now invoke getAreaThird, which is also a nested function inside inner function. However, it has its own local variable of pi, which has been set to 3.14. The value of pi in its closure, of course, is 3.1. So, does a local variable override a closure variable of the same name? Well, the answer is yes. So getAreaThird has clearly referenced the local variable pi, whose value is 3.14. And so the area of the circle has been calculated as 314. So with our different function calls, we can see here that local variables override closure variables, which in turn override global variables of the same name. Continuing with our experiments though, we will now invoke getAreaFirst using the second circle variable, which has been declared inside inner scope. So does this affect the value of pi which is referenced? Well, the answer is no. getAreaFirst still uses the value of pi declared in the global scope, which was 3. So the area of second circle with a radius of 20 has been calculated as 1200. So where the argument has been declared doesn't seem to matter in this case. It is where the function is declared which determines the value of pi which is being accessed. To really confirm that, however, we will now invoke all of the remaining 3 functions we have declared using second circle as an argument. And we can see here that getAreaSecond still references the closure variable pi, which has a value of 3.1, as does getCircumference. Hence the values of 1240 and 124 for the area and circumference. And getAreaThird still uses 3.14 as the value of pi, which is its local variable. So we can now just continue performing some confirmations of what we have observed. Before we get to that, let us comment out all of these function calls as well as the console messages. And heading over to the global scope, we will now invoke getArea first using first circle as an argument. When we perform this invocation from inside inner function, the value of pi which was referenced was 3 and the area was calculated as 300. And we get the same output this time as well, confirming that it is where the function is declared rather than where it is invoked, which determines what variable is being referenced. This is because, as discussed, a closure is made up of a function along with its enclosing environment. Heading back to our source now, we can invoke getAreaSecond using first circle as an argument from the global scope. And unsurprisingly, we get a reference error because getAreaSecond is declared inside inner function, so we cannot reference it from this global scope. Heading back to the source, I'll just comment this out and then make sure there are no more errors in the code. And we can now invoke getArea first using second circle as an argument. So given that second circle is declared within inner function, unsurprisingly, we get a reference error once again. So I'll just comment out these calls here. And now it's time for us to declare one more function. So this is called getAreaFourth, which again accepts a circle as an argument and will calculate its area. And within that, we declare a variable pi, which is set to 3.142. So this is the most precise of our pi declarations so far. getAreaFourth has a nested function called calculateArea, and this references pi in order to calculate the area of the given circle. So far, this declaration of getAreaFourth seems similar to getAreaSecond defined inside inner function, except this time we will have getAreaFourth return calculateArea, which we will invoke after our call to getAreaFourth. So, heading back to the global scope, we will first print out the value of pi within the scope and then invoke getAreaFourth by passing along first circle as the argument, which of course has a radius of 10. We expect that what is returned by getAreaFourth is not just a function, but in fact a closure, which includes the calculateArea function along with the value of pi in its surrounding environment, which is 3.142. And to confirm which value of pi is being referenced, we will now invoke circleArea. And from the browser, we observe that even though the value of pi in the global scope is 3, the calculated area for first circle has referenced the closure variable of pi, which is 3.142, and this has overridden the value of pi declared within the outer scopes. So there have been many different scopes we have played around with in this demo, and you hopefully have a much better understanding of how closures can affect the scopes of variables. So far in this learning path, we have observed that a JavaScript closure includes a nested function along with its enclosing environment, which typically includes variables in that environment. In this demo, we will observe that closures effectively boil down to the maintenance of a state of the environment of a function, which means that we can implement counters. To demonstrate this, we once again have an HTML and JavaScript. And within the JavaScript itself, let us go ahead and then implement a function called counter. Within this, we declare a variable called count, which we initialize to a value of 0. And then we have a nested function called increment count, which references the closure variable of count. Each time increment count is invoked, it will increment the value of count by 1 and then return that value. And the counter function itself will return the increment count nested function along with its enclosing environment, which includes the count variable. That is, it will return a closure. So this is what we need in order to implement a counter in JavaScript. But it's time now for us to invoke it. So we have a variable count function, which will get the value returned by the counter function. This, of course, is the closure, which includes the increment count function along with the enclosing count variable. Effectively, the variable count is maintained in the state of count function, which is why we will be able to access it repeatedly. To test that out, let us now go ahead and invoke count function, and this should give us the value of our counter. So we head over to the browser and bring up the HTML, and when we head over to the console, we observe that the value of our counter is 1. Since this is maintained within the state of the count function, if we were to head back to the source and then invoke it for a second time, we should get a value of 2. And when we head over to the browser to test this out, that is exactly what we get. So the value of the count variable is one which is simply maintained within our count function variable. It does not get reset to 0 at each invocation of count function. Just bringing up the counter function declaration, each time we invoke a count function variable, it is the nested function which is invoked, that is, the code within that is executed, which increments the value of count and then returns it. The setting of count to 0 is something which is only executed when the counter function is called and not when countfn is invoked. So heading back to the source, we can confirm this by invoking count function repeatedly. This time we do it 6 more times within a for loop. And from the browser console, that the counter does indeed maintain its state and it gets incremented by 1 each time. Now, what if we were to create another counter function, which is conveniently called another counter function? So we invoke counter for a second time. This again will return the closure, which includes the increment count function along with its enclosing environment. And the question is whether this will have any effect on our already existing count function. First though, let us invoke another count function for once. And when we head over to the console, we see that this returns a value of 1. The invocation of the old count function is still giving us the values of 1 through 8. Moving along, we invoke another count function for a second time. And sure enough, this maintains a state as well and then gives us a value of 2. Now the question is whether this has any bearing on the previously created count function. So do we have 2 independent counters, or our count function and another count function referencing the same count variable? Well, let us head over to the source and then invoke our original count function one more time. And this returns a value of 9. So the state of that function is independent of the another count function. So we have now seen that closures allow us to effectively maintain a state comprising the variables in the surrounding environment of a nested function. And this is what allows us to implement counter functions in JavaScript. Having count functions does allow us to configure web pages to behave in a certain way, and this is something we will explore in the next video. So far, you will have some degree of experience with closures in JavaScript, and you also know that we can use them in order to implement count functions in the language. Since one of the main applications of JavaScript is in configuring the behavior of web pages, in this demo, we will take a look at how we can configure buttons on a web page to implement counters in the backend. We once again make use of an HTML and a JavaScript source file, but this time we will be focusing a little bit on the HTML. So in addition to pointing to a source file, which is our JS file, we have two different buttons declared within this HTML page. The first of these has an ID of Inc button and contains the text increment, and then correspondingly we have a decrement button as well. As you can imagine, once a user presses each of these buttons, it will increment or decrement a value. Just below the buttons, we have declared two different div elements where we will render those incremented and decremented values, and we will revisit this HTML just a little later in this demo in order to fill in some more details. For now though, it is just important for you to know that there are two buttons on our HTML page, and we will get these to point to two different functions, one to increment and one to decrement a value. Speaking of those functions, we will need to code those into our JavaScript source. So I'll just head over to that, and we will now declare a function which will execute as soon as the page loads in the browser. We can do this by setting a function value to the property window.onload, and this of course references the global window object. This is just one way of getting code to run after a page loads in the browser, and one more way to accomplish the same feat is to include the script tag in our HTML at the very end, after all of the elements have been declared. We will continue with this approach, however, for this particular demo, where we reference the increment button declared within our HTML, and we retrieve the button object by invoking document.getElementById. We then declare a variable called incCount, which keeps count of the number of times the increment button has been hit. So this is initialized to 0. Following this, we attach an onClick property to the increment button. So this is again going to be a function, and this is where we increment the value of the incCount variable, and then we display this incCount value in one of the div elements following the buttons in our HTML page. To do that, we first retrieve the div element by invoking document.getElementById once again, and the ID of that element you will recall is incCount, and then following that, we update the inner HTML of that element. So the incCount div element will display the number of times the increment button has been hit. We can do this because the onClick function declared here references the incCount variable which has been declared in its enclosing scope. The incCount variable is initialized to 0 only when the page loads. However, its state is accessible by the onClick method, which is how we effectively implement a counter. To test this out, let us load the HTML in a browser window, and we can see here that the two different buttons are available on the page. Just pulling up the console and heading over to the element section, we can explore the HTML as we defined it, and this is in fact the DOM or the document object model of our page. We have discussed earlier on in this learning path that JavaScript has the ability to update this DOM. For now though, I will draw your attention to the div element at the bottom of this DOM, which has the ID of incCount. Because when we hit the increment button, we expect that to be updated. Let us go ahead and do exactly that. As soon as I hit the button, you see that the page gets updated where the increment counter is equal to 1 message pops up. And you'll observe now that even the div element seems to have been updated. I'll hit the button once more, and the increment counter has been updated for a second time. And to view exactly how the DOM has been updated, we can expand this div element, and we see now that the inner HTML now reads increment counter is equal to 2. So we can see this update both on the page as well as the DOM. Hitting the button for one more time, you can see the updates take place at both the DOM and the page levels. And I just keep hitting this a few more times. So we have successfully incorporated an increment counter on our web page. However, we have not really set a function for this decrement button. We can do exactly that, and I'll now head over to the source code and then declare a dec count variable in the global scope. So this is going to be outside of the onload function. Given that the script tag in our HTML has been included before any of the buttons have been declared, this decrement count will be initialized to 0 before those buttons have been loaded. However, we need to assign a decrement function to the decrement button, and we can do that only once the page has loaded. So we now retrieve the decrement button from inside the onload function. Before we link this button to a function, let us declare the function itself, and this is going to happen outside the onload. So this is called countDec, and you can see that this kind of mirrors the function which we declared for the increment button. So in this case, we decrement the value of the dec count variable, and then we display it in the inner HTML of the dec count div. Now, to link our button to the function, we head back to the onload function, and right after the button is retrieved, we set its onClick property to our countDec function. So while we assign the onClick property of the increment button to an anonymous function, in this case, we declare the function and point the decrement button's onClick property to it. Alright, now to carry out our tests, we head back to the browser and reload the page. So the div elements below the buttons are now blank. Let us go ahead now and invoke the increment operation once. This has updated the DOM for our page, and we can just expand this div element and confirm its contents. Moving along now and hitting the decrement button. And the div element for that has also been updated, and we can confirm it from the DOM here. So we see that both the incount and the dec count divs have been updated. So at this point, our counters for both incrementing and decrementing values have been successfully incorporated into our page, and you can just go ahead and continue playing with these buttons in order to make sure that the DOM gets updated with each click. We have previously seen in this learning path how the scope of variables in JavaScript is affected by closures. We will now continue exploring that by incorporating objects into our code and view the interactions between closure variables and object variables. So for this, we have an HTML and a JS, and this is called closure scope. And heading over to the JavaScript itself, let us first enable strict mode and then declare a variable in the global scope. So this represents the boss of a number of employees, and let's just say at the beginning, the boss's name is Margaret. Following that, we have a function constructor, and this represents an employee, and this takes in two arguments, a name and a title. These arguments are assigned to the objects themselves. So we set values for this.name and this.title, and also set a domain property to data. We now include a function within this object, and this is called intro, and this we can assume is what an employee will use in order to introduce themselves. So how exactly do they do that? Well, we first construct a title for an employee called empTitle, And this is in fact a combination of the domain as well as the title for the employee. Do take note though how exactly this emp title variable is constructed. We reference the domain field as this.domain and the title as just plain title. Given that this intro function is in fact a nested function within a function constructor, it means that title here references the title argument which was passed at the time the employee was constructed, and not the title property of the object. Don't worry if that sounds a little vague at the moment. We will soon see exactly what that means. However, do note exactly what the employee's introduction is. So when we print out this message to the console, we are referencing the name of the employee as name, and note that this is not this.name. We reference the boss, and presumably this is the boss declared in the outer scope, and then we reference the emp title variable. So in this case, we have references to local variables such as emp title, to the object properties such as this.domain, to the closure variables of name and title, and also to the global variable of boss. Alright, in order to test out the different scopes of the variables, we can first initialize a new employee called Troy, whose name is unsurprisingly Troy, and we give this employee a title of analyst. Troy's domain will be set to data. So when we invoke Troy's intro function, we will need to see how exactly the different variables are accessed and constructed. So we can save down the source file and then pull up the HTML in a browser. Once the page loads, we can just pull up the console and we can see Troy's introduction. So the name is accessed as Troy, which of course is the closure variable. The boss, which is the global variable, is accessed correctly as Margaret. As for the title for Troy, this has been constructed as data analyst. Data has been pulled from the object property and analyst from the closure variable. Now, what happens if you were to head back to the source and then update the boss? So let's just say Troy's boss has changed from Margaret to Wolfgang. Now, if we were to invoke the introduction, does this pull in the new value of boss, which is declared in the global scope? Or is there some local value which is different from this global value? Well, the answer is that the new value of boss is being pulled. So Troy's introduction now references his boss as Wolfgang. So by updating the global variable, we are in fact getting an updated introduction. Now let us try and update the domain for Troy. So we now update the object property to ML instead of data. So with this change, when we introduce Troy, is he still a data engineer or will he now call himself an ML engineer? So from the browser, we can see that updating the object property has updated the introduction as well. Troy now describes himself as an ML analyst, and you can see here that since emp title references this.domain at the object level, updating the object property does affect the value of emp title as well. This is because each time the intro function is invoked, it reconstructs the emp title as this.domain plus title. The title itself, though, is not referenced as this.title, which means that it is the closure variable rather than the object property which is being referenced. To see what effect this has, we can go ahead and then update the title at the object level for Troy. So Troy is no longer an analyst but an engineer, and we can see whether this has any bearing on how Troy introduces himself. And from the browser, we see that there is no change in the introduction at all. So Troy still calls himself an ML analyst, and this is because the variable title, which the intro function accesses, is the closure variable, which was initialized when the employee object for Troy was constructed and is still retained in the closure environment for the intro function. This is separate from the object property of title, which is why Troy's introduction still shows him to be an analyst rather than an engineer. To confirm this, we head back to the source and we'll just print out the entire Troy object to the console. And we can see here that the title has been updated to engineer. But if you were to expand the intro function, and then specifically if you were to go and expand the scopes, we see that within the closure itself, the title still reads as analyst. So there are two different title variables which the intro function could potentially access. There is one in the object scope, which has a value of engineer, and then one in the closure scope, which is analyst. Unless we use the this keyword, it is the closure scope title which will be accessed. In addition to the closure scope though, this function also has access to variables in the global scope. So when we expand that, we can see that the variable boss is accessed as Wolfgang from within this global scope. We will now continue playing around with the scopes of variables in JavaScript, which includes closure scopes, but we will now take a look at block level scopes as well. To explore that, we head back to the source code, and I'm just going to comment out all of these object initializations as well as console statements first, and then introduce a new function definition called myFunction. So this is mainly to demonstrate the use of a function in JavaScript called setTimeout. This is one which will execute a function after a specified time. That is, it defers the execution of the given function. So in this case, the first argument to setTimeout is the function which needs to be executed on a deferred basis. So in this case, we define an anonymous function which simply writes out to the document the text hello. And the amount of time after which this function will be executed makes up the second argument of setTimeout, which is 10,000 milliseconds, or just 10 seconds. In order to test it out, we will now invoke myFunction, and then following that, let us pull up the HTML in the browser, and once we go ahead and reload the page, we will need to wait about 10 seconds for the document to be updated. And sure enough, the text hello has been printed on the page. So we now know how the setTimeout function works, and let us use that in order to see what happens when we create multiple closures within a for loop. So heading back to our source code, we can just comment out this function declaration and invocation, and now we declare a new function called timeout test. Within that, we declare a variable called I, and then we use that variable inside a for loop. So we are iterating over the values of I from 0 to 3. So we have 4 for loop iterations, and inside each of them, we will invoke a function call using setTimeout. So we effectively create 4 different function calls here, and each of them references the value I and prints it to the console. So note here that the timeout value has been set to I times 3000 milliseconds, and this is to ensure that the function executions are staggered rather than being executed all at once. This is because the for loop itself will run very quickly and then create these 4 function calls. So the functions themselves will be created at about the same time, but by deferring their executions by different times, we ensure that they don't return simultaneously. So what exactly is the effect of this for loop? Well, in each iteration, we create a new function, specifically a new closure, which prints out the value of I to the console. The question now becomes whether the value of I within each closure is independent of all of the other closures, or whether they are pointing to the same variable I. Well, there is just 1 way to find out. So we invoke this timeout test function, And when we head over to the browser and refresh, we see that the first function has printed out the value of 4, and that is the same function printed out by the second and third invocations of the function, and also the fourth. So it looks like all 4 of the closures which we generated within the for loop were in fact using the same variable I, since the for loop itself will have executed very quickly and then initialize the 4 different closures. The value of I at the end of the for loop was already 4, and that was the value of I which each of the functions were able to access when they did start executing. So this is something we need to be mindful of when we create multiple functions, specifically multiple closures, from inside a loop where they all end up pointing to the same variable. So heading back to our code, how exactly can we ensure that each of the functions which prints out I to the console is working with its independent copy of I? Well, we don't declare I within the closure, but in fact we define it at the block level. So in this case, the variable I is declared at the for loop level, and it is the value of I which will be passed in to each of the 4 functions. So saving down our changes and then reloading the page in the browser, we get the values of I from each function call, and they now appear as 0, 1, 2, and finally 3. So this is one more illustration of how one needs to be careful when creating closures in JavaScript. And you should also be mindful of the fact that you may end up creating a closure inadvertently when you are just looking to create a function. The demos in this learning path, and specifically within this course, will have covered the fact that it is possible for us to perform a lot of cool operations using closures in JavaScript. In this demo, we will take a look at how we can implement getters and setters using closures. So now that we have an HTML and JavaScript, we head straight over to the JavaScript source, and within that, we declare a function called getterSetterData. If you have any prior experience in object-oriented programming, you will probably know that getters and setters are functions which are meant to enable access to private variables of an object. Well, we have covered the fact earlier on in this learning path that within any function in JavaScript, if we declare a variable using the var keyword, then it effectively becomes a variable which is private to that function. In this case, we declare a variable myvar and initialize it to a value of 1 inside getterSetterData. Now, for this variable to be accessible outside of the function itself, we need to define functions within getterSetterData which will perform that access for us. So, we can now get this function to return an object which includes the function definition itself. So this object includes a function called getVar, which returns the value of myVar. This getVar function is a nested function, which is in fact nested inside an object, which in turn is inside the getterSetterData function. This still means that it does have access to myVar as part of its closure. To test it out though, we can go ahead and create a new object called objvar, and its value is the object which is returned by an invocation of getterSetterData. So we can now use this objvar variable in order to invoke the getter function. So we called objvar.getVar, and to confirm that this returns the value of 1, we pull up the HTML in the browser and then head over to the console, and the value of 1 is indeed printed out. So we have now successfully implemented a getter using closures in JavaScript. Alright, heading back to our source, we can complete the definition of our object by including a setter function as well called setVar. This accepts an argument of v and then updates the value of myvar to v. So this is pretty much a standard setter function. To make sure that it works, we will invoke objdvar.setVar and we will update the value to 2, and then we will make sure that the value is indeed updated by making a call to the getter function right after that. And when we head over to the browser, we can confirm that both the getter and the setter work exactly as expected. MyVar was initially 1, then we invoked setVar in order to update its value, and that has successfully changed to 2. In fact, heading back to our source, we can set the value to a string as well, and this is possible because the JavaScript language is dynamically typed. That is, a variable is not bound to a specific type. So we now update the value using setVar and then retrieve the value using getVar, and this returns the newly updated string value of the variable. So we have seen previously that it is possible for us to effectively have private variables within a function constructor in JavaScript if we declare it using the var keyword. And we now know that it is all possible thanks to closures. So far in this learning path, you have covered one of the crucial and also somewhat complicated concept in JavaScript of closures. It is now time to take a look at another important concept of prototypes. In the theory section of this learning path, we cover the fact that prototypes are the way in which inheritance is implemented in JavaScript. We also discussed that properties, including functions, which are common to the objects built out of the same object constructor, can be defined within the prototype for that constructor. We will now take a look at exactly how that can be implemented. So we once again have an HTML and JavaScript, and as with most of the demos, we head straight over to the JavaScript code. So once strict mode has been enabled, we will now define a function constructor to represent a student. This accepts just a single argument, which is the name of the student. Within the constructor itself, we set the value of the object's name property to the input name, and then define a function in order to calculate the average score of that student across an array of courses. That array is passed as an argument to this constructor. So note here that we're making use of the reduce method in order to calculate the total aggregate score, and then we divide it by the length of the score array in order to get the average. Alright, so this is a simple enough object constructor. So we can go ahead and initialize some objects from it. The first of these represents a student with the name of Heidi, and we also work with a second student called Ralph. Now, we can calculate the average scores for each of these students, and for that we pass in an array of scores in 3 different courses for Heidi and Ralph. So we invoke the average score methods for each of them. Now both the Heidi and Ralph objects in this case have their own copy of the average score function, and they will be using their respective copies in order to calculate the average scores. So let us go ahead and see what the averages are. For that, we pull up the HTML in a browser, and once it loads, we head over to the console. So Heidi has an average score of 67, while Ralph's average is 74. Alright, this is simple enough, but let us confirm what exactly is present within each of the Heidi and Ralph objects. So we head back to the source and print out the entire objects to the console. And heading back to the browser, we can examine what these objects contain. So expanding Heidi, we see that this object includes the name property as well as the average score property, whose value of course is a function. Expanding that, we can see exactly what the function involves as well. But let us minimize this and head over to the Ralph object. So this also includes the name field and its own copy of the average score function. Now this is not the most efficient design of our object constructor, since the average score function is something which is common for both of these objects. Having 2 copies for each of the objects we have created is not the best use of our available resources. While this is not such a big factor when we only have 2 objects, if you end up having thousands or potentially tens of thousands of them, you'll need to have a better design. So let us head back to our source code and then implement a prototype into which we can move the average score function definition. So we define a new object constructor called studentProto, which, much like the student object constructor, will accept a student name. And this also includes an average score method, but this average score is part of the studentProto prototype. So do note how exactly we set this prototype here as studentProto.prototype.average score. And then the body of the function is exactly the same as in the previous object constructor. With this design, no matter how many instances we create of studentProto, all of them will point to a single instance of the average score method, and that method itself will be part of the prototype for this object. Alright, let us now test things out by redefining the Heidi and Ralph instances, and these are now going to be of type studentProto. And following that, we will invoke the average score methods for each of them. This time, they will be invoking the same average score which is present in their prototypes. Alright, heading over to the console. When we reload the page, we get the exact same average values of 67 and 74. So by defining the average score function as a prototype, we get the exact same output as before, but with better resource utilization. Well, to confirm that, let us head back to the source and then print out the entire Heidi and Ralph objects to the console. And when we head back to the browser, upon expanding Heidi, we see that it's just the name which is part of this instance. And it is also the case with Ralph. If you want to see where exactly the average score method is, you can expand the Dunder Proto field here, and you should see the average score listed there. I will skip that, however, and will instead head back to the source code, and we will now see how we can define fields within the prototype as well. So within the studentProto.prototype, we now add in a new property called UniName, and this we set to a value of XYZ. So with the single change to the prototype, we will now print out Heidi.UniName as well as Ralph.UniName. If they are indeed pointing to the same prototype, we should be able to see XYZ printed out in each of these cases. And from the browser, that is precisely what we see. So it is now clear that both of the instances of our student object are in fact pointing to the same prototype. Heading back to the source, let us confirm this by updating the UniName property from XYZ to XYZ University, and we will print out the UniName properties for both of our instances. And the browser confirms that in both of these cases, the change has taken effect. So when we have common properties for objects built out of the same object constructor, whether the values for those properties are functions or just regular strings, we can define them within the prototype for those objects. In the previous demo, you are introduced to the concept of implementing prototypes in JavaScript, and we will now continue exploring how different properties of an object can be accessed, whether they are defined within the object themselves or within an object's prototype. So from the browser, we head back to the source code, and we will now define one more object constructor, and this is called student multi-proto. This is because we will have multiple prototypes within this object constructor. The first of these is a property UniName, and this we set to a value of XYZ. So this is a property set within the prototype for student multi-proto, which means that all instances created from this object constructor will have the same value for UniName. On the other hand, the name attribute for every instance will be unique to that instance itself. So we assign this by using the argument passed into the constructor. And then following that, we define a prototype function called average score. And this, of course, accepts an array of scores and calculates the average value. And then beyond that, we introduce one more prototype function called intro. This simply prints out to the console a message which includes the name of the student as well as their university name. So the name is accessed as this.name, and this will be present within the object itself, whereas the uni name field is something which is present within the prototype. So the question is, will an instance of student multiproto be able to access the uni name using the this keyword? Well, the answer is yes. This is because of something known as the prototype chain in JavaScript. So JavaScript objects have properties which are defined not only within their object constructor, but they inherit the properties which are defined within their prototypes. And this is something we will test out when we create new instances of student multiproto. So we redefine the Heidi and Ralph variables which we created previously and set these to be new student multi-prototypes. And then following that, we will invoke the average score methods for each of them, which of course belong to the prototype. And to test it out, we head over to the browser and reload the page. And the average scores are correctly calculated and printed out. It's now time for us to invoke the intro method for each of these objects. So we first call Heidi.intro and then follow it up with a call to Ralph.intro. So will these intro methods be able to access the name property as well as the uni name property, which is defined within the prototype? So from the browser, we get that the answer is yes. Just to confirm that the uni name is not part of each individual object, we will now print out both of the objects to the console once more. And we can see here that for the Heidi object, it is only the name property which is present with the object itself. And heading over to Ralph, we see that the same applies to this object as well. So how exactly did the intro function access the uni name property? Well, within the function definition, when we invoke this.uniname, JavaScript will first look for the uni name property within the object itself. If it is not found there, it will go one level up to the object's prototype. In our case, that is precisely where the uni name attribute was found, and in effect, the Heidi and Ralph objects inherited that property from their prototype. In JavaScript, it is possible to have multiple levels of prototypes, in which case any reference to a property will keep looking one level up the prototype chain until that property is found. Alright, so now that we have a nice introduction to prototypes, let us see how we can make use of the class keyword in JavaScript in order to implement an object constructor. We have already seen an example of a class in JavaScript previously in this learning path, and we have also seen the use of the extends keyword in order to implement inheritance. For now though, let us try to recreate the behavior of our student object constructor in the student class. So this is declared using the class keyword, and within it, we define a property called uniname, which we set to a value of xyz. Following that, we have a constructor method, which accepts the name as an argument and assigns it to this.name. And then we have an average score method, which accepts an array of scores and returns its average. And finally, we also include an intro function, which prints out the student's name along with their university name. We will now redefine the Heidi and Ralph objects to be of type student class, and we do this by making use of the new keyword, just like with an object constructor. Previously, we have discussed the fact that classes in JavaScript are merely syntactic sugar over object constructors as well as prototypes. And one of the reasons for its inclusion in JavaScript is to make it easier for programmers in Java or C++ to transition to JavaScript. Since this syntax to create classes and create objects out of those classes is similar to the ones in those object-oriented languages. So now that we have these new Heidi and Ralph objects, let us invoke their average score methods. And from the console, we get the exact same output as before. And heading back to our source, we will now invoke the intro methods, first for Heidi and then for Ralph. And we can see from the browser that it does print out the values for their names and their universities. Now the question is whether the uni name in this case is in fact unique to each instance of the student class, in which case we will find a uni name property in both the Heidi and Ralph objects, or whether it is part of some common prototype. Well, to confirm, we will now print out both the Heidi and Ralph objects to the console. And from the browser, we can expand the Heidi object. And we see here that this includes all 4 of the properties which we defined within the class. These include the name and uni name fields, as well as the functions of average score and intro. So by default, when implementing classes in JavaScript, any property which you define within it will be a separate one for each instance which is created from the class and is not part of the prototype. If you'd like some properties, including functions, to be common across all instances of a particular class, then you could make use of the static keyword, which is also available in JavaScript. Once again, that is just syntactic sugar around the implementation of prototypes, which is why I won't be covering that in this course, but feel free to explore it on your own. The purpose of this demo is to implement inheritance in JavaScript using prototypes. We will also cover how multiple levels of inheritance can be accomplished and how properties can be accessed up the prototype chain when we have these multiple levels of inheritance. So given this HTML and JavaScript, we head straight over to the JS file again. And once strict mode has been enabled, we define the object constructor for a vehicle. So this is going to be at the root of our prototype chain. During this demo, we will define 2 different types of vehicle, one of them being a car and the other an aircraft. And for the aircraft, we will define a subtype as well. In the root prototype, however, we will only declare all of the common properties. And in order to distinguish between the different types of vehicle, we include a type property whose value is set by the constructor. Beyond that, we also include a default implementation of a function called print details, and this will simply print out the type of vehicle to the console. So this is a rather simple implementation of a vehicle object constructor. We'll now define a special type of vehicle, which is a car. So this constructor takes in 3 arguments, the make, model, and the number of driven wheels for the car, and these become properties of every car object. In just a little bit, we will define the prototype of this car to be a vehicle, which means that it will inherit the type property as well as the print details function. However, we can override the print details function within every car instance, and this function will print out the type, the make, and the model for each car. So this is how we can override inherited properties in JavaScript. Also, in this console.log statement, you'll observe that this.make as well as this.model are available within the car object itself. However, this.type will be accessed by looking up the prototype chain at the vehicle. So we now have a vehicle object constructor and also one for a car, which is a special type of vehicle. And we'll now define one more vehicle type, and this is an aeroplane. Just like a car, an aeroplane also has a make and model, and we also define the number of engines and the type of engine to the constructor for an aeroplane. In this case, we do not override the print details method, which means that it will inherit the default from the vehicle. So now that we have defined a car and an aeroplane, we have not yet implemented any inheritance. And for that to happen, we will need to set the prototype for a car, which we set to a new instance of type vehicle. And when doing so, we need to assign the type property for a vehicle, which we set to car. So any car instance which we create beyond this will have a common property of type whose value is car. And even though it also inherited print details from the vehicle, that has been overridden by its own implementation. So let us now go ahead and create a new car instance. This represents a Volkswagen GTI, and this is a car which is driven by its front wheels. So now that we have this new car object, we can go ahead and print out the entire object to the console and view its contents. First, we save down this JS file, and then we pull up the HTML in the browser. And once the page loads, we head over to the console. So we can see the car object which has been printed out. And when we expand it, we can see each of its properties. So the make, the model, as well as the driven wheels are present here, as well as the print details method which we overrode. You can also see in the dunder proto dunder field that its prototype is a vehicle. So the object seems to be as we expect it to be. So let us head back to the source and then invoke the print details method. So this is one which references the make and the model properties, which are defined within the car instance, but it also references the type attribute, which it inherits from the vehicle prototype. So to make sure that it works, we head over to the browser and reload. And we can see here that the print statement does give us all three of the details. The values of Volkswagen and GTI have been pulled from the object itself, whereas the value of car was found by looking up the prototype chain at the vehicle prototype. Heading back to the source now, we will now assign the prototype of the aeroplane object constructor to be a vehicle as well, but this is going to be a new instance of vehicle where the type is aircraft. Following that, we create a new instance of an aeroplane, and this is going to be an Airbus A320, which has two engines, and the engine type is a turbofan. These four values which we supply will be set to the four properties of an aeroplane object and two other properties. A type field as well as a print details function will be inherited from the vehicle prototype. First though, we will print out the entire Airbus A320 object to the console, and from the browser, we can see that this does indeed possess all four of the attributes which we defined. And upon expanding it, we can confirm that its prototype is indeed a vehicle. Now it's time for us to confirm that the print details method was indeed inherited from the parent. So we can just minimize this and head back to the source and then invoke Airbus A320.printDetails. So if the inheritance is successful, this will not throw an error and will print out the vehicle type to the console. And this is precisely what occurs. So the print details method has been successfully inherited by this Airbus A320 object. This method is of course common to all instances of aeroplane. So if you were to create additional instances as well, they will all be referencing the same print details method, and when invoked, their output will be identical to what you see right now. So we have now successfully defined a common prototype object constructor for a car as well as an aeroplane. In the next video, we will introduce one more level of inheritance by creating a special type of aeroplane. In the previous video, we created two instances of a vehicle, one of a type car and the other of type aircraft, and we set those as prototypes for an instance of car and aeroplane. It is now time for us to introduce one more level of inheritance, that is one more level in the prototype chain. Since we have already defined an object which represents an Airbus A320 aircraft, we can use that as a prototype for several variants of that aircraft. Now, every variant of an Airbus A320 will have the same details which we supplied to an Airbus A320 object here, where the make will be Airbus, the model will be A320, the number of engines will be 2, and the engine type will be a turbofan, which is precisely why we can use this object as a prototype for the different variants. To understand what exactly this variant represents, let us dive right in and then implement an object constructor for an Airbus A320. So each variant will have its own variant name as well as its own wingspan, and may also have its own factory location where it is manufactured. When we assign the previously created Airbus A320 object as the prototype for this particular object constructor, the make, model, num engines, and the engine type properties will be inherited from that, as will the type as well as the print details method, which will be inherited from the vehicle prototype. However, in this case, we will choose to override the print details, which is inherited, and define a new version. So this references a number of fields which are defined all the way up in the prototype chain. So the reference to this .type will only be resolved when we go 2 levels up the prototype chain, all the way up to the vehicle, this .make, as well as this .model, and also the num engines and engine type properties will be resolved by going 1 level up to the Airbus A320 object, which we will assign as the prototype. But the variant name, the factory location, and the wingspan will be available within the object itself. So we now assign Airbus A320.prototype to the previously created Airbus A320 object. So for every instance of Airbus A320 which we create, which will represent variants of that aircraft, they will share the same Airbus A320 with a lowercase a as the prototype. We can now create one such instance. So this is called A320 Neo, and this is going to have the properties of Neo as the variant name, as well as 36, which is the length in meters of the wingspan, and this is manufactured in the city of Hamburg in Germany. And once this object has been initialized, we will invoke its print details method in order to view all of the details of that aircraft. And once again, we are making references all the way up in the prototype chain in order to construct the print statement. And when we head over to the console, we can see that all of the different fields are indeed being accessed as expected. The value aircraft is being accessed from the vehicle prototype. The values Airbus and A320 come from the aeroplane prototype, whereas the value of Neo came from the A320 object itself. So heading back to the console, we can now print out that A320 Neo object and view its contents. So from the browser, we can see that this itself includes the 3 different fields along with the print details function which were defined. So on expanding it, we can see here that its proto field in fact points to vehicle. So we have now successfully implemented multiple levels of inheritance in JavaScript using prototypes. This course delved into 2 of the crucial aspects of JavaScript programming: closures and prototypes. We started off by exploring how JavaScript functions don't exist in isolation, but include references to data in its surrounding environment to form a bundle which is referred to as a closure. We explored how the presence of closures influences variables defined in several scopes, and also how counter functions can be implemented using this concept. We then moved on to how prototypes allow us to define attributes which are common to all instances of an object constructor, and also how they can be used to implement inheritance in JavaScript. Having completed the labs in this course, you will have covered some of the most difficult topics in JavaScript and can consider yourself quite fluent in the language. You will have all the skills you need to begin using JavaScript to influence the behavior of the client side of your web app, such as manipulating the document object model or DOM of a web page, and listening for and handling events.